So, let's look at some density calculations. You've got a sheet. It should have been delivered to your teams, and it looks like this when it's printed out, although you of course, don't have to print it out. And there's a bunch of things to do, but you need 3 drinks. You need something like Gatorade in cool blue. You need something like Minute Maid lemonade. And you need something like distilled white vinegar, my favourite drink. Now that last one's not going to work, so I have to put it aside because it's not something that contains sugar. So what I'm looking at today is what effect the sugar content has on the density. And you, of course, have kitchens at home, and kitchens are the most fabulous chemistry labs of all. So, there's a number of things you need to do here. We'll have a look at those in a video I do at home. But home's just the same as school because you, of course, have lots of very, very precise measuring instruments. You've all got a wide range of beakers available. You've all got a balance that is precise to 0.001 grams, haven't you? So let's see what we do if we have got all this equipment. So, firstly, we've got a measuring cylinder. And we pop it there. And it's a certain number of grams in its mass. But we're not interested in how many grams that is. We're going to zero that. Then we're going to take some of the drink. Let's try the Gatorade. I'll just put a bit in the small beaker, just like the one you've got at home. And I'll make sure there's a bit more than 10 milliliters in there. Because I want to fill this to 10 milliliters. In order to do this, I have to look from the side and make sure that I measure to the bottom of the meniscus. Drat. Almost. The top of the meniscus is at 10. The bottom of the meniscus is at the 10. Now that reads 10.317 grams. And this is 10 milliliters. A milliliter is the same as a cubic centimeter. So this is, let's divide it by 10. It is 1.031. And let's forget about the last decimal point. But we've got a density in grams per centimeter cubed. That's nice. Now we do it again. And we don't need to do anything to that. Let's zero it. And that's a 0. We don't care about what that is because we're now going to put another 10 milliliters up here, which means my next bottom of the meniscus measurement has to be at 20 milliliters. Nice. No, top of the meniscus is there. Get a little bit there. That'll do. So now, this one, it says 10.148. I divide that by 10, and it's 1.01489. 1.015. Okay? So, looking at this, we've got some densities. You also are supposed to measure the temperature because you all have a handy little digital thermometer here at your home, I'm sure. That is extremely precise. And you'll find that this is... Oh, you'll find a temperature when it stops moving. But my thing here gives me 14.4, which gives me a precision of 0.1 degrees Celsius. So, there's a bunch of other stuff to do on the sheet, and you'll be able to do that yourself. But obviously, at home, you're not going to have access to all this equipment. What your job is to modify this experiment using the equipment you've got at home. See you at home.